My name is Alan Lightman. I'm a scientist and a writer. My family has a home on a small island in Maine. The island has no roads or bridges, and there's no ferry service. One summer night, in the wee hours, I was coming back to the island in my boat. I was alone on the water. I was captivated by the quiet and the stars overhead. I decided to turn off the engine. I lay down in the boat and looked up. After a few moments, my world dissolved into that star-littered sky. The boat disappeared, my body disappeared, and I found myself falling into infinity. I felt as if I were part of the stars. I was merging with something much larger than myself. And the vast expanse of time, extending from the far distant past, long before I was born, and then into the far distant future, long after I'll be gone, seemed compressed to a dot. What was happening to me? As a scientist, I used to think that everything could be reduced to numbers. But at that moment in the boat, I believe you could have hooked up every neuron in my brain to a giant computer, and all of that data wouldn't have come close to explaining my experience. After a time, I sat up and started the engine again. And so began my personal journey to understand how these different worlds relate. The world of atoms and molecules, and the world of complex human experiences. In a material and impermanent cosmos in the age of science, what is it that has meaning? And how can we find it? What's the difference between matter that's alive and matter that's dead? Could we actually make life from scratch? Creating life from simple chemistry would be the ultimate proof of the materiality of living organisms and us. It's quite possible that this breakthrough will occur in Jack Szostak's laboratory. Professor Szostak won the 2009 Nobel Prize for his work on how DNA ages. But then he moved on to a completely new subject, the origins of life on Earth. I have a friend who's a pretty smart guy, and he thinks that life could not have originated on Earth because there wasn't time to create all of the molecules needed for life.
There's lots of evidence and lots of really modern recent evidence that it's actually quite easy to make the molecules of life and that they can be made very quickly.
What does it take for us to decide that a thing is alive?
If we're most interested in, once you have the right chemical building blocks, how do they come together to make a simple cell, something that can grow and divide and start evolving and eventually lead to more complicated forms of life? What I care about is a system that can start to evolve in a Darwinian sense. But the other half of what we need to create a simple living system is that membrane boundary, the vesicles that form from simple lipids.
A vesicle is basically a compartment that contains RNA and other stuff of the cell. Szostak is trying to understand how vesicles and RNA can be created from the simple chemicals present in early Earth.
I came to this lab because I'm very fascinated by the idea of the protocells, which is the primitive cell forms on the early Earth.
So what Stephanie has done is she's created these vesicles, which originally were all fairly large, like these, and then she's added into the solution more of the fatty acid molecules that make up the membranes. They go into the membrane and cause it to grow, and then the membrane starts to fluctuate, and the vesicles divide and start generating all the smaller vesicles that you can see forming. And it's so simple, right? There's no fancy cellular machinery. There's nothing that's evolved. It's just very, very basic chemistry and physics that's driving everything that we see.
Other researchers are experimenting with how simple chemistry can copy information and even evolve in conditions completely unlike those on early Earth.
So one very interesting thing about these reactions is that the liquid that's in here is not water. This is chloroform for these ones, which is a very different solvent than water.
So if you can prove that you can get a non-RNA molecule to replicate in a liquid environment that's not water, would that increase the possibility of life elsewhere in the universe?
It's hard to say really absolutely, but I certainly think it would.
It seemed to me that Jack would have some pretty clear thoughts on that mechanism versus vitalism debate that had been puzzling me. My understanding is that almost all biologists today are mechanists rather than vitalists.
Absolutely. I mean, nobody has ever come across anything that requires any supernatural explanation. I think it's because we understand more and more about biology in terms of its molecular structure and organization.
So are we all just atoms and molecules?
It's not just atoms and molecules, it's the organization. There are layers and layers of emergent phenomena where when you have collections of molecules and sources of energy, you get interesting, new, and often surprising phenomena. Common in life, but also in other purely physical systems. If you combine informational molecules that can replicate with some kind of physical spatial localization, for example, membrane-bound vesicles, then you have new phenomena that can occur, like Darwinian evolution. And so now you're off and running in a totally new ballgame.
You once said that you hope that when we do succeed in creating something that we would call a living thing, you hope that the public understands that the creation of life is totally natural.
If we can show that there is a kind of continuous pathway of straightforward steps that connects chemistry, the environments of a young planet, to the emergence of biology, then I think it would be logical to just accept life as another natural phenomenon. I mean, it's no less wonderful or beautiful because we understand that there's a natural origin for it. And so understanding how we're a product of nature right from the beginning, I think builds on that view that we're not something separate and different, but we're a part of nature. And we should accept that and live with that.